The next thing that we're going to look at is special forms, and special forms are going to be a lot easier than what we've done in the previous section, mostly because they're special. One of the first things that you need to be able to do in order to do special forms is you do want to be able to recognize your square and cube numbers. If you need to make a note of these on the side, you may want to do that. You also need to understand your rules for combining and multiplying sign numbers. When talking about special forms, one of the first ones that we're going to look at is difference of squares. In terms of everything that we factor, it is one of the easiest to recognize as it only has two terms. One thing to note is since the middle term is missing, then the factors must be exactly the same except for the sides, since the insides and outsides cancel out. So let's look at a few examples of this. Let's start with A. So let's look at a few examples of this. Let's start with example A, which is x squared minus 4. I'm going to again start off by writing my two sets of parentheses. What multiplies to x squared? Well, in the previous sections we saw that it has to be x and x. What multiplies to 4? Well, you have 1 and 4, but we don't want to use that since we are talking about special products. 4 is a square, and so it is equal to 2 times 2. Since our last term is negative, we want our signs to be different, or if you want, because it is difference of squares, our signs are different. The last thing that we want to do is let's just check it and see exactly why we get this as our answer. If we multiply our firsts, we get x squared. Our outsides is 2x. Our insides is minus 2x. And our lasts is minus 4. Note here that our middle terms cancel, leaving us with x squared minus 4. So that is the correct factorization. Let's look at a second example. Our second example is 81x squared minus 49. Now, in the previous section, we saw that when we had larger numbers, this could be rather challenging. But if you can recognize this as difference of squares, then this is actually very easy. In terms of 81 is equal to 9 and 9. We need x's with both of them. 49 is equal to 7 and 7. And since this is a minus sign, we do have different signs. If we go ahead and check this now, we can multiply our firsts, giving us 81x squared. Our outsides multiply to 63x. Our insides multiply to negative 63x. And our lasts multiply to minus 49. Again, notice that the insides cancel. So our final answer is 9x minus 7, 9x plus 7. For our final example, let's go ahead and look at 9 minus 16x to the 10th. This one looks a little weird, but it's still going to be about the same difficulty level as the previous one. To start off with, let's go ahead and factor out our firsts. Our firsts, what multiplies to 9? 9 is a square, it is 3 and 3. What multiplies to 16? As is square, we get 4 and 4. X to the 10th, if I wanted to break that in half, what times itself equals x to the 10th? Hopefully, you will see that it's going to be x to the 5 and x to the 5. Remember that when we're talking about multiplying variables with exponents, We want them to add to 10. So what plus itself equals 10? That's going to be 5 and 5. From here, we can go ahead and put in our signs. They are different. And we can go ahead and check using FOIL. If we multiply our first, we get 3 times 3 is 9. Our outsides, we get plus 12x to the 5th. Our insides, we get minus 12x to the 5th. And our lasts, we get minus 16. Add the exponents, we get x to the 10th. Our insides cancel again, leaving us with 9 minus 16x to the 10th. So our factorization is 3 minus 4x to the 5th, 3 plus 4x to the 5th. And that is basically difference of squares. Our second example that we want to look at in terms of special products is a perfect square trinomial. In this section, it is the easiest to recognize only because it's the only one that has 3 terms. But once we start mixing the problems together from all of the sections, it may be a little harder to recognize. One thing to note, you can still use all of the previous techniques that we've looked at. But one of the things is, before you begin, if you notice that your first term is a square and your last term is a square, it doesn't hurt to go ahead and try it as a perfect square trinomial. So let's go ahead and see what we can get with these ones. Let's start with example A. With example A, what we're going to do is we have our 2 sets of parentheses. The only thing that multiplies to x squared is x and x. And now for the 9, I want to know what times itself equals 9. That is going to be 3 and 3. We still have the same rules about our signs. In order to multiply to a positive 9, we know that they are the same, and in order to combine to a positive 6, they both have to be positive. You can either write this in factored form or in expanded form, or if you want, you can go ahead and write this using exponents, which is going to be x plus 3 squared. If we go ahead and check this, let's go back to our factored form or our expanded form and multiply it out. This is equal to the first, we get x squared. The outsides, we get x times 3 is 3x. The insides, we get 3 times x is 3x. And the lasts is 3 times 3 is 9. If we combine our middle terms, we get x squared plus 6x plus 9. So our correct factorization is either one of these two right here. Let's go ahead and look at example B now. So for example B, we again have that our firsts are going to be x and x. We have our lasts. I want something times itself that gets 64. That's going to be 8 and 8. Notice that our last term is positive, meaning we need to multiply to a positive number. That tells me that my numbers have same signs. And if my numbers have same signs, when I combine them and get a negative, that means that I want them both to be negative. So we get x minus 8, or x minus 8 squared. If we check this, we start off with our firsts. X times x is x squared. Outsides, we get negative 8 times x is negative 8x. Insides, we get negative 8 times x is negative 8x. And lasts, we get negative 8 times negative 8 is positive 64. When we combine our like terms, we get x squared minus 16x plus 64. Let's go ahead and look at example C now. Let's look at example C now. If we had used the techniques from the previous section, meaning writing out all the possible factors for 25 and all the possible factors for 36, this would actually be very challenging. But one thing to note is 25 is a square, 36 is a square, and so we're just going to go ahead and assume that this is a perfect square trinomial, especially since we are in the special product section. So let's see what we can go ahead and do. What times itself is equal to 25? We should get 5 and 5. Both of these will have x's. For the 36, in order to multiply to 36, what times itself equals 36? We should get 6 and 6. We do have that our signs are going to be the same in order to multiply to a positive 36, and they are going to have to be negative because in order to combine two negatives, we keep the sign. So I will have 2 negatives, and here's our factorization. We can also write this as 5x minus 6 squared. If we check this, we want to start by multiplying the firsts. The firsts give us 25x squared. Outsides, we get 5x times negative 6, we get minus 30x. Insides, we get negative 6 times 5x is negative 30x. Lasts, we get negative 6 times negative 6 is positive 36. When we combine our like terms, we get 25x squared minus 60x plus 36. That checks out, and therefore my correct answer is one of the two here. Let's go ahead and look at example D now. Similarly on the last one, if you recognize that this is perfect square trinomial, it's very easy. Note that 16 is a square, so is 25. So let's go ahead and just factor it as a perfect square trinomial. What times itself is equal to 16? We should get 4 and 4. I want to put x's with both of those terms. If we come over to the 25, what times itself is equal to 25? We should get 5 and 5. And I want to put a y with each one of those as well. Finally, in order to multiply to a positive 25, my signs have to be the same. And in order to combine numbers with same signs and get a positive, then they should both be positive. That leaves me with 4x plus 5y and 4x plus 5y, or 4x plus 5y squared. If you want to check it, you may, but it does come out to be correct. That takes care of our perfect square trinomial. As you can see, this is easier, much easier than any of the other ones that we've had to do. The main thing is knowing what a perfect square number is. If you aren't sure what a perfect square number is, make sure that you have these as a reference off to the side.